In this video, we will start our discussion on the transformations of functions. The very first type of transformation we will talk about is called horizontal shifting. Horizontal shifting occurs whenever you add or subtract something on the inside of your function. This is what I mean by that. Do you see how this has x plus 3 on the inside of these parentheses and it's all cubed? Well, this is based on the parent function, x cubed. And if you remember, the x cubed function looks something like this. Hopefully you get the idea. It's something very similar to this, although my graph's not very pretty. Well, if you have a plus 3 on the inside of the function, for horizontal shifting, it does something kind of odd. It does the opposite of what you think it's going to do. So instead of moving to the right 3, since this is a plus 3, we're going to actually take this graph and move it to the left 3 places. So this entire graph would shift 3 units to the left. So it would end up looking something like this. So what would that next one look like? For this one, your parent function was, let me come over here on our scratch paper, the absolute value of x. And if you remember, the absolute value of x is something like this. It's V-shaped. Oh, pretend like that's a straight line, not curved. So it's V-shaped, just like that. Well, since this has a plus 2 on the inside of those absolute values, it's going to take this graph and shift it 2 places to the right. So that one would end up looking something like this. The next type of shifting is called a vertical shifting, and this happens whenever you add or subtract something on the outside of a function. Now, I don't know if you remember this exactly, but if you have 1 over x cubed, 1 over x cubed was something like this. And then the origin is between those two. So the origin would be here. Well, if you have a plus 4 and the plus 4 is on the outside of the function, it's going to take this graph and shift it up 4 units. So if that happens, it would look something like this one. So how about the fifth root function, that g of x right there? Well, I don't know if you remember this one either, but if you have the fifth root of x, or pretty much an odd root, it's going to look kind of like the cubed function, but on its side. So the fifth root of x looks something like that, and of course, the origin would be right in the middle, right in here. So if we have a minus 3 on the outside of this function, it's going to take this graph and it's going to shift it down 3 units. So that one would end up looking something like this. We have 1, 2, 3. So you can see right there is where the origin used to be. So we took that graph and shifted it down 3 units. Now what about reflecting? For this one, the graph of the function g of x is negative f of x is the reflection of the graph of f with respect to the x-axis. Oh my goodness, what in the world does that mean? This is all it means. If you have a negative on the outside of your function, so the function itself is negative, it's going to reflect over the x-axis. Now for the next one, if you have a negative on the inside of your function, a negative x on the inside of your function, that means it's going to reflect over the y-axis. So what exactly would this first one look like? Remember, your x squared function is a parabola that looks something like this. Well, if you were to stick a negative in front of that x squared, all it does is reflect it over the x-axis. So it ends up looking like this one. So what if you have the square root of negative x? Well, remember, the square root of x looks something like this. So if you were to put a negative underneath the radical, like this one, it would take this graph and reflect it over the y-axis. And it would end up looking like this one. How about stretching and compressing? Let's see how this works. If you multiply your function by some number, that's what a is right there. If you multiply your function by some number that is greater than 1, it will be stretched vertically. It gets stretched this way. I think about if you were to take me and put me on a stretching machine, it would make me tall and skinny, right? So if it's stretched vertically, it makes your graph tall and skinny. However, if you multiply your function by a number that is between 0 and 1, say you multiply it by 1/2, that's between 0 and 1, or 2/3, or 5/6, anything that's between 0 and 1, it's going to stretch it horizontally. Of course, in this lesson, we're going to call it compressed vertically. So it's kind of like squashing it, so that makes it get short and fat. If you compress it vertically, that means it gets pretty much squashed, and it gets short and fat in that case. So let's look at a here. This is the same thing as f of x equals 1/6 times the square root of x. Remember from the previous page, the square root of x looks like this. Since we're multiplying it by a 1/6, that means this graph gets compressed. It gets stretched horizontally, or it gets squashed this way, which means it is compressed vertically. It ends up looking something like this one. The next one we have the square root of x function. Not the square root, the absolute value of x. Remember, the absolute value of x is this graph that goes off in both directions at a 45-degree angle. So whenever you multiply this function by a number that's greater than 1, it's going to stretch it vertically. It's going to make it tall and skinny. So it ends up looking something like this one. Instead of going off at 45-degree angles in both directions, this way and this way, it gets stretched, so it gets tall and skinny. There is an order to the way you should work your transformations. It's kind of like you're working your way outward from the function. The first thing that you want to do is figure out what the parent function is. So have a look at this. The parent function is actually a square root because there's a square root in it. So think about what the parent function looks like. This is your square root function. Well, look at your horizontal shifts next. That means what else is underneath there or inside the function with the x? We have a +1. With that +1, that means it shifts to the left one place. The next thing that you want to do is look at the stretching and compressing. Well, we're multiplying this by a 2. Don't worry about the negative just yet. We're multiplying it by a 2. That means it's going to get tall and skinny. It's stretched by a factor of 2. And because of that negative, which is the reflecting, it gets reflected over the x-axis. So it's still left 1, and it's still tall and skinny, but it's flipped upside down. Then you look at your vertical shifts. We have a +3 out here. Because of that +3, it takes this graph and moves it up 3 units. That's why it starts here. So this would be the final graph of that function. So let's sketch the graph of the function f of x equals 1 over 1 minus x. So the very first thing that you need to do is remember what the function 1 over x looks like. Well, the function 1 over x looks like this one. Now, what happens whenever we put this plus 1 on the inside? Or if we were to rewrite this, this is the same thing as 1 over negative x plus 1, right? So we need to figure out what's going on here. Well, what is going on? Notice how we have a plus 1 inside the function? Because of that, it's going to take this graph and shift it to the left 1 unit. So once we do that horizontal shift, it would look like this one. So what did we just do? We just did 1 over x plus 1. But what happens with this negative that's in here? What does this negative inside the function do? The negative inside the function will make it reflect over the y-axis. So you take this entire graph and you reflect it or flip it over the y-axis. If you do that, your final graph would look like this one.